Now that we've finished learning about central angles, today we're going to learn about another type of angle in the circle called an inscribed angle. And this is an angle inside the circle that is not a central angle. And the reason that it is not a central angle is because the vertex is not on the center. So as we learned with central angles, the vertex is on the center, and that makes it a very nice, easy situation. But that is not always the case. Today, when we talk about inscribed angles, these will have their vertex on the edge of the circle. And these are called inscribed angles. Inscribed angles. Okay. So this is the second case with angles and arcs. And I'm going to show you what these two pictures can look like. I think it's important to understand that inscribed angles can look like this. Notice that B is the vertex, and B is not in the center anymore. It's on the edge of the circle. But notice this is also an inscribed angle. B is still on the edge of the circle, but one of the pieces, one of the rays of the angle is sticking outside the circle. That's okay. That is still inscribed. And I just like for you guys to see the different ways that an inscribed angle can look. Now, the formula for both situations is still the same. I'm going to highlight them over here. Let's talk about them. The angle is now equal to half of the arc. So if we know the angle or we know the arc, we can figure out the other. It's going to be really important that we write down that formula because then that will help us with what to put into the Desmos calculator. So filling out the notes, when the vertex of an angle is located on the circle or on the circle's edge, the angle measure is half of the arc measure. Oops, so sorry about that. Moved ahead. So for example, here we can see, and I'm going to highlight a couple here. We have angle ABC. We can see that B is on the edge, and that's our vertex. So this is an inscribed angle. So we say that angle equals arc divided by 2. And then we have to figure out how to substitute the information that we know into the circle. If you look at this angle ABC, it touches the edge of the circle here at A and here at C. So the arc that is intercepted with that inscribed angle is 60. That 60 is going to go here. And we want to know the measure of angle B. Most of us are comfortable dividing by 2, but if you are not, you can go over to the Desmos calculator and do just a simple division problem, 60 divided by 2, and get 30. So the measure of angle B is 30. In this next problem, the measure of RT, that is an arc. But if you look at the picture, R to T that we want, we're going to make that X. That particular arc belongs to an inscribed angle. So we have to use this same formula. Angle equals arc over 2. And this is where most people make their mistake. They think that the 63 gets divided in half, but really it does not, because in this situation, this 63 is the angle measure. That 63 is sitting right inside the vertex. So when we substitute information into the equation, that has to go there. And this is where a lot of people make their mistake. They would take the 63 and divide it by 2, when in reality, when we solve this and we cross multiply, we would be multiplying both sides of the equation by 2. Now, this is where I think it's a good idea to show you what it looks like in the Desmos calculator. And when you find your answer, you will get 126. If you notice, 63 times 2 is 126. That's what you're doing here. You're taking this 2 and this 63 and you're multiplying them. You're using the properties of algebra to multiply those two together. Now, let me just extend the page a little bit so that I can write that. So that means x is the arc, which is 126 degrees. So you just have to be careful. Now, this third problem is a little tricky because they want arc WX, and WX does not belong to an inscribed angle. In this particular case, this is our inscribed angle, and it belongs to arc WY. So we're going to find arc WY, and then we'll worry about WX in a moment. So I'm going to put an X here. I'm going to write down my formula. Angle equals arc divided by 2. And in this case, my 57 is inside the angle. That is my angle measure. I want to know the arc measure. So when I multiply by 2, and again, I can do that right in the Desmos calculator. It'll do it for us. I'll get 114. 114 degrees. But that's not my final answer. That's this arc from W to Y. I need to find W to X. So the thing that we have to remember here is that YX is a diameter. So that makes all the way around from X to Y is a semicircle. And I'll write that right here. And remember that semicircles are worth 180 degrees. They are half of the circle. So if I want to find arc WX, I'm going to subtract 114 from the 180. And again, you can do that in your Desmos calculator. You'll get 66 for that little piece. So sometimes there are 2 steps to these problems. When we come back, we will be on page 16 in the packet. We're going to practice going back and forth from angles to arcs or arcs to angles. And then we will continue on with that onto the next page. And I'll show you a couple of very special cases that happen with inscribed angles. These can be very interesting, but they always confuse students a lot. And then I will show you what the ALEKS problems can be very complicated with central and inscribed angles. So I will see you in just a couple of moments. Thank you for watching.